Hello and good afternoon. Are you guys still awake? Okay, ready for the next 45 minutes of boredom? Okay, no, seriously. Thanks for the great talks. I actually didn't have the chance to catch everything today, and I just got 4 hours of sleep last night. But it's great to be here. I really enjoy it. It's also my first MUM, and it's great to be there with the first MUM in the Philippines, mainly because I live here. So. Okay, so today we're going to talk about implementing a university backbone using MikroTik's Cloud series. This talk is by intention or intentionally less technically, okay? So we're going to talk about more on the organizational side and yeah, just lean back, relax, but do me a favor, try not to sleep. All right, so I'm gonna, there's a lot of people here. Yeah. All right, a few words about myself. I'm in touch with MikroTik's since 2013. I did a lot of other stuff in regards to networking before. I'm in the field for almost 12 years now. I speak fluent German and Ruby. So, and if you want to let me know about your superpowers, you can connect to me on LinkedIn. So I don't want to bore you with all my, Vita, whatever. You can just check out my profile and then ask me questions if there's anything coming up. Okay, so what am I doing here? I live here, not in Manila. I don't like metropolitan areas too much, mainly because of the pollution. I live in the Visayas. I live in Dumaguete, and I'm the head of IT operations for Foundation University, and it's the home of the Greyhounds. And we have 2 campuses that are based in Dumaguete. We have a main campus and we have a north campus. We're actually fairly small. We have only a population of about 3,000 to 3,500 students, so it depends completely on the time of year because we also have some parts of our curriculum that are not available all the time because they're not that demanded all the time. We have about 12 colleges. It covers literally everything, agriculture, nursing, education, college for computer science and all that stuff. We have a very, very, how shall I put this? I think there's no easy way to put it. Yeah, we actually pretty much, we have a great advocacy for environmental change, okay? So we're trying to make everything as green as possible. So, and we also aim to become a MikroTik Academy by next year. So this would be basically the first MikroTik Academy in the Visayas, except for the Mindanao State University, which just popped up a couple of weeks ago on a MikroTik website, and I was not that happy anymore that we would be the first one. Unfortunately, I didn't find anything about their curriculum or their schedules or anything on their website so far, so I don't know how far they are, but I'm pretty sure that when we start, we're going to be well working together. So, all right. My team is I'm the head of IT operations, so I lead the IT operations team. So we're responsible for a majority of things. We're an internal workforce. So unlike other universities, especially within the public sector, actually the other way around, especially in the private sector, we do everything internally. So we don't use external contractors. So everything from system provisioning all the way down to the network, we pulling fiber optics, splicing, we do everything ourselves. So we also do infrastructure and software development. In fact, we were one of the first universities, this was way back in time before I joined Foundation. We already had online enrollment almost 10 years ago. So we do planning and realization of IT projects, everything in-house, but we also have a lot of entities connected to us. In fact, we have a bank, including security systems and stuff like that. But we also connect to private entities that we actually as part of research projects that we actually offer for the students, and it's like really big sites, unplanned installation for fiber optics, long-distance Wi-Fi communication, and all that stuff. So our facilities are being managed 24/7, so that's what we take care of. So when someone calls me at home, and I live in the university village, which is barely 7 minutes away from work, yeah, well, I'm the one to get up, drive to the university, and make sure that everything works. And that's the same for these 2 guys over there that are sitting there, the one with the blue and the black shirt. That's my deputy, Emran, and that's Cliff Richard Perez. That's one of my network administrators. You will see another talk from him right after mine. He will actually talk about some whispering in the province kind of thing, whatever that is. And proactive system monitoring. So we monitor all facilities and we take care of the management. Okay, first, before we start, I need you to understand what actually went down in the past years since I joined Foundation. Hello? Okay. Okay, still on. Actually, it was opting out with George before as well, so that's getting worse. So first I need you to understand what actually happened till 2012 as I joined Foundation. We're in the province, right? We're not here in Manila. Everything that we do looks a little bit different from what's going on down here in, Manila, right? In the capital. So let's start this way, okay? So this was our department before. There's a lot of historical stuff that was piling up, okay? So when I came in, initially I saw this. So this was actually, I think, the second week I was there. And what we actually decided to do was, first thing that came into my mind was, oh my God, where do we start? You know? And then this whiteboard here was my best friend by the time, and every day for 1 week, every morning for 3 times, I was actually writing down all kinds of stuff. You know, I was teaching my guys some basic stuff in regards to networking, system engineering, blah, blah, blah. Telephone circuits, blah, and all this kind of stuff. Try this. Hello? Wow, sounds not different. Okay, so we did exactly that, right? So I was standing there literally every day, and I was writing down stuff, ideas. Where do we go from here? You need to know I consider myself a very progressive guy. You might not actually notice it, but I can also socialize. It's not one of my superpowers, but I'm capable of socializing. So don't be afraid to talk to me afterwards. I might seem a bit moody once in a while, but I think I'm a great guy once in a while. All right, so after we sorted out, we had about 3 of these truckloads. All right? That's the truck from the scrapyard just around the corner. They were happy, actually. I think they were paying us $50 per kilo. All right, so this was the office before. We had actually, all these service areas that you can see here on the side where all these CRT monitors and all this other stuff was actually stored and left for that, okay? So, and the problem was with this office that this is where the windows were. So when you were sitting in there during daytime, it was not just freaking cold, it was freaking dark, and you got moody immediately because you were just, trying to wrap yourself up into a cubicle and just go like, hello, what am I doing here, right? So it was really, really awkward, and it was not really a nice situation for anyone that was involved. So what we did is we reconstructed the entire office. We did floor raisings, we pulled Cat 6 shielded fabrics through the floor. We did a grounding, new fresh electrical installations with German fabrics. Then we actually we have our own architecture department. Long story as well, but we also, why is this skipping all the time? The presentation is fairly large. I didn't minimize it. So these tables and all this stuff. So we really redesigned everything from scratch. So in about 3 months, we redesigned the entire office and made sure that everything is a proper working space for everyone to let the ideas flow. So in the meantime, we actually had a backup Isp Uplink. Actually, by that time, yeah, that was our backup, right? So there were actually 6 and 8 Mbps, so 14 Mbps all in all. I think that was it. Or was it 12? I don't know. Anyways, these were the 2 grid antennas, and that day I was so happy because I was climbing up the water tower and I was like, no more. Because that was really bad, because these guys, they were really doing something that didn't work at all. Okay? When we had outages, it was like, calling the phone, it's like, hello, when do we have a connection back? Oh, maybe next month, or we have to check first, right? And that doesn't work at all. So we teared it down. Then we started the initial termination of patch panels and stuff like that, right? If you wonder what this is, I'm holding a sword and I'm trying to terminate a patch panel, literally. But so we had everything up and running by the second quarter of 2013. So within just 6 months, we did a really good job on that, and the team was really euphoric about everything. It was really great. So it was operational, even though it was improvised. You can still see that the termination here, the patch cables and everything, it was still hanging down. So, and then we started actually implementing our first radio links using RB2011. So, and since I'm one of these guys, I don't like to do prototyping that much, okay? What I like to do is I buy stuff, I implement stuff, and then I let it run until it dies, okay? That's not for the software part. Of course, we keep on upgrading that stuff. So we got racks in and all this kind of stuff. So basically, rack-mounted enclosures for, hinged installation of walls and stuff. So this is actually our first distribution point on campus. It is on top of the dormitory. This is connecting our backup link to the bank. The bank actually meanwhile has a fiber uplink as a primary link, but this is connecting the bank as a backup link, our university village, 2 farms, and some other spots. So this is our long distance communication center point until this month. Cliff will talk about this later. So this was the first projects where students were proactively involved. They were involved with the design, they were involved with the implementation, and they really got the nosebleed of a lifetime because they were never really challenged that much. The educational system was not really providing for this, so we took them at hand and we just, dragged them into the field, and we really gave them a lot of stress. However, it was really nice for them because they really learned something, and you can be sure that they're going to apply this, in the future if ever they decide to stay in the field of IT. So then the first high-density switch chassis arrived, which we really needed. Why am I telling you this? Because we run our entire campus backbone on PoE, actually native PoE on 48 volts with detection according to IEEE 802.3 AF. I like standards, you can tell. And also new UPS systems and all kinds of stuff. Then the first batch was actually done. Well, good job. Unfortunately, this is the best batch that we had so far. And very, very, very rare, we also had a girl in there. And she was also kicking some ass, seriously. So, yeah, this is how it looked like when we started implementing our new backbone. So we actually, we have 3 data facilities. One is being built up right now. One is at the main campus near our office, and a second one at the computer college, because these are the spots where we have the highest density of, let's say, we need the highest throughput. Okay, so this is where storage and server systems are located. So then, in the second quarter this year, we had, after we designed actually the 10 gigabit backbone, which I'm talking about here, we got all the routers and everything in that we actually ordered, and testing began. And as you can see here, students were also involved, and they were pretty happy as they saw, oh my God, I can really push 10 gigabit full duplex or wire speed. They never see that before. They never seen that. For them, a gigabit interface was already, oh my gosh, that's the future, right? So let's run the numbers. So first of all, operational metrics, okay? We're going to talk about some mobile clients here. So we have right now around, this is just an average, 800 mobile clients around campus. This is daily average. That's really not that much. But for us, it is much because we have budget constraints that we have to deal with. And still, we want to put something up that people can use in order to train and that they can reuse for other universities. So everything we do is not just for foundation. We'd like to take all the specs, throw them into the wild, and see it evolving, okay? So we have about 350 wired workstations. The trend, of course, is going down due to the fact that we migrate most of the stuff to mobile devices because it's simply more flexible and part of our educational system already. Then we have about 300 infrastructure hosts. Wow, now you think, oh my God, 300? Well, I already count in the management IP addresses for switches and all that kind of stuff, access points, all this kind of stuff, everything, including routers. So our primary uplink, and this is extremely rare, we decided to drop all our existing uplinks because they were all not satisfying, and I couldn't sleep at night knowing that, anytime something might happen. So what we did is we got in touch with PLDT, and we run an iGet uplink straight into the university from the Makati core. And that's actually, by next, I think February, we will have a static STM1, which is actually 150 Mbps lease line. Okay, and that one has no downtime for the past 6 months. You can say whatever you like about PLDT, and of course it's like SME, alpha, blah, 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 right? We got this done, implemented in less than 3 months, including everything, okay? Provisioning, everything, literally everything. Record time, okay? Usually that takes more than a year in our place, okay? Don't ask me how I did that. I just managed somehow. Then we have a secondary link right now. So right now we're on 100 Mbps. That's actually barely enough because we have a utilization from 80 to 90%. Because the entire educational system, maybe I'm just going to start over this way. The mobile client density is based on the fact that as one of the first university in the country, and that's what we're really proud of. I'm not proud of the fact that we implement actually Apple, but that's a different story. We implemented iPads or let's put it in a broader spectrum. We implemented mobile computing into the educational system. That means they become an essential tool for all the students within the grade school and high school grades in order to learn. So they're an integral part of the educational system of our curriculum. So you can think whatever you like about it. There are many aspects to it, and I'm the first one to say, oh my God, Apple, sorry, that's so proprietary, and that's definitely not for education. However, I don't want to discuss this today, at least not right now. So we have about 40,000 active connections, and we have about 150 to 200 inserts and removals per second. So this is just for some of you who are interested into this, technical stuff. Are there any questions in regards to the metrics? Because I'm pretty sure there's like tons of stuff missing that you guys might be thinking about. None? Voila? Okay. So, yeah, challenges when designing a campus network. So here are the challenges that we were actually faced with. So the first challenge was to provide proper training for all the personnel that would be involved with operating the backbone. So why is that? Because we decided to implement MPLS. Okay, so that's pretty harsh, especially if you don't know anything about it. Okay, so we try to avoid a single point of failure, and avoiding a single point of failure when it comes to this kind of complexity, that's really, really harsh, especially in the environment that we're working in. So we've been struggling a lot with budget constraints and a slow supply chain. I don't have to explain to you guys, and I know that this is going to be on the record, but I just gonna say it anyway. I don't have to explain to you guys how the status is on how to when you operate radio communication gear in this country. I don't have to explain to you how this works, right? Okay, so in terms of slow supply chain, we get most of the stuff from the outside. I have to admit it. We have to get most of the stuff from the outside because down here, and I know the reasons for that, everything is 60% more expensive. Okay, I know the reasons for that. That's not the point, okay? I'm not blaming anyone, I know that it's not just your margin for those suppliers here. I know that there's a lot of stuff involved, right? Even though slow supply chain, that was really one of the major issues. Even now, 2 years after, I'm still waiting for 3 new rack-mounted enclosures to arrive. I have no hope, actually. So the upcoming pressure of the K-12 program. So what is K-12? So those of you, and for all the Filipinos, which is majority here anyway, who of you knows the implementation of the K-12? Please raise your hands, just so that I know who knows about K-12. Okay, so that's just a handful of people. All right, so who's involved with the educational sector down here? Who's doing educational work? Not training, and we're talking money. All right, I mean, who's working with schools, for example? Anyone? It's a handful of people, okay. So to explain it in a nutshell, the K-12 implementation is gonna make us all die. Okay? That's the bottom line. And I'm really that blunt with it because especially for the private sector, for 2 years, for 2 consecutive years, starting 2016, we will have literally 0 enrollment on the college level. Have you any idea what kind of hole this is gonna blow into our pocket? You think I gonna get another MikroTik router, even if it's like a small RB951 or something for $50? Forget about that. That ain't gonna work. Okay? So this impact, this pressure that we have in the back now all the time, this is really, really, really hard to deal with because we know that by end of next year, I mean, right now we're already putting up reserves and everything, and we have to counter, and we already feel the impacts of it. So our enrollment this year was already lower than the year compared to the year before. It was catching up just slowly due to the, this mouth-to-mouth propaganda, like, Manila Bulletin said that private schools are going to die due to the K-12 implementation by next year. Boop, 200 enrollees less. Okay, that's not funny at all. So, but this is how it spreads. So that's a very, very big issue. And of course, seamless integration of our existing infrastructure. This is a legacy infrastructure. We have like tons of unmanaged STP, spawning tree. Yeah, it's cool if it works. But if you don't have even switches that support it, I mean, it's like everything's unmanaged. It's like one hell of a nightmare in terms of loops. So, yeah. Right. So. Okay, so what are the benefits? So let's talk about the benefits rather than the challenges. We have a great price-performance ratio, unbeatable. It's unbeaten. It's as simple as that. MikroTik has the best price-performance ratio. We also have a feature-rich operating system with a small footprint, meaning it fits on any kind of appliance. We can have embedded systems, but we also can have brutal x86 systems for whatever purpose you see fit. Then affordable flexibility thanks to MPLS and VPLS. So it eliminates the need for a conventionally switched network. So does anyone know why switched networks were actually so much in trend and so trendy over the past couple of years, or let's say the past 15 years? Exactly because the routers, I mean enterprise routers that had this kind of functionality that's offered by RouterOS were simply too expensive. We're talking about enterprise gear or enterprise grade gear with routing, switching backplane, forwarding backplane, blah blah blah, all this kind of stuff. I mean really enterprisey. Whatever enterprise means in that context. Anyway, but that's why we actually decided to go for, or that's why most businesses decided to go for switched or conventionally switched Ethernet bridged networks, because it was a cost thing. You didn't want to waste that much money on routing infrastructure. Nowadays, our 10 gigabit backbone was less than $5,000. $5,000, geez, I can't even buy a single enterprise router for that. If I go for, officially buy it through all the support channels and licenses and run it through everything, it ain't gonna work. It's as simple as that. So it also supports hardware-supported virtualization. So that means we have a lot of use cases for this. We have cloud, we have Green IT, Meta router on Tilera. So meaning we can run a lot of virtualization, Meta routers, especially on the new cloud core routers. The newer ones, I just took a look at it and I thought it was a myth until I saw it. But I forgot the type actually. I don't have the catalog here. But it's on the front. It actually has 8 SFP plus cages. We're talking about 80 gigabit, okay? 160 gigabit full duplex wire speed. I mean, this is crazy. That monster has 72 cores. This is crazy. This is just amazing, seriously. Thanks for that, MikroTik. And even though that thing didn't release any prices so far, but even if it's $1,500, I get it. Seriously, because it's nice. And we, of course, and this is something very important, though I'm an open source, let's put it this way, I'm a free software and open source guy, okay? That means all my stuff is mainly open. I don't like proprietary solutions. I made an exception for MikroTik. So for research and learning, for me, everything should be open. However, there is no other platform on the market right now that can, even partly compete with MikroTik in terms of what kind of functionality is provided. And additionally, since it's Linux-based, RouterOS is Linux-based, right? Since it's Linux-based, everything that you learn in a RouterOS class, or when you do your CNA or CRE, whatever, if you do your certifications, most of the stuff that you learn you can apply on a plain Linux box, okay, on a plain Linux system with a NetFilter framework and so on. So it works almost the same, and that's cool because you don't need to learn things twice. So if you know how to configure RouterOS, you know basically how to configure a Linux firewall system. So that's pretty cool. So that's why we actually, that and also the fact that Cisco gear is simply, oh my god, I said it. I'm so sorry. That gear is actually so expensive that it is not feasible for students to buy that gear or even apply it in their private field, for example, at home. That's that's one of the reasons, but not the major reason, but that's one of the reasons why it's simply not feasible to have a CNAP program at a university. That's my personal opinion. I have people that I work with every day. They have a different understanding of this, and this is perfectly fine. They have a different idea about it. But for me, when we work every day, we work for a better result of the whole university or for a better outcome for the students. We don't just work for ourselves or for our bloody careers. We commit ourselves to the university and to the system in order to raise students that we can throw into the field that are able to survive and that are pretty much capable of handling themselves. So we're just giving them ideas and then just, kick them into real life. And that's what studies for me is all about. So sharing knowledge. And that's why we're actually planning to possibly, that's not fixed yet, but possibly replace the CNAP program with the MikroTik Academy by the first quarter of next year. Right now we have 3 trainers. So actually, Cliff, me, and Emran, we actually finished our MTCNA and the CRE already. Unfortunately, we have to leave tomorrow morning, so we can't attend the other courses. But we're now certified, so we have 3 trainers already. So for the MikroTik Academy, that's supposed to be enough. And now we're going to get started. So we're going to train our own people, and we just try to build this up and, get going. So, all right. So let's get to the core of this entire talk. So we're going to talk about our network structure. It's not too technical, so I don't want to make you guys sleep anymore. So we have 10 CCR 1036AG2S plus EM. Wow, that's cryptic. Okay, so it's a cloud core router with 36 cores, 8 copper-based gigabit ports, 2 SFP cages, SFP plus, meaning they support 10 gigabit, and this is the extended memory version. Okay. This one is 36 core, 12 gigabit ports, and 4 regular SFP cages. We use this mainly for, I didn't explain what we use these for, but it's pretty obvious though. We use this for 10 gigabit ring topology to power our MPLS backbone. I'll show you the topology in a moment. I mean, the physical layout, and the logical as well. So, it's freezing cold in here, by the way. So we have 1 gigabit uplinks for the fiber optics. So we actually use these for distribution because due to budget constraints, we couldn't afford buying more of the Cloud Core Router series. Right now, it's really tight. So we rather actually prefer to go for 20 more RB2011, which we can always reuse somewhere else for base stations or for office installation, distribution, whatever. And so for the moment, we use these. And they're also MPLS enabled, of course, same router as. And this is our fiber optical layout. This is our main campus. So, and I know that this overview is you can't tell what this is. I give you a heads up. So these are actually 20 meters. Hold on a second. What's this? Let me just check over here. Can't read this. Yeah, I think right. So basically, these are like 20 meters per dot. Okay. So on the upper and on the lower portion. So these are our core spots. So we have one core spot over here, which is our computer college, college for computer science. This is our main data center facility in the IT operations office. And over here we have the Office of Finance and Administration. High density spot for mobile clients and also for distribution because we have most of the classrooms located over here and most of the stuff is hardwired. So we have we have 2 switching chassis with up to 196 ports over there. And this is our core. This one here is the layout for the North Campus. And you guys on the back, you can see it better because this projector has issues with displaying the colors. But the red ones are actually fiber optics and the blue ones are actually legacy-based copper links. This is not actually, these overviews are not fully recent. I didn't manage to. Actually, I didn't want to update them. I was really too tired last night. I'm so sorry. But most of these copper-based links were already replaced with additional fiber optical links. Each cable, we use actually like you do here in the streets or anywhere around, we use 12-core single-mode fiber. So, all right. This is really bad with this projector. This is really bad. Couldn't get any worse, possibly. Yeah, well. Excuse the icon set. Okay, this is the icon set for network diagrams. I'm so sorry for that. Unfortunately, those are also open source and they're part of the program that I use to make these kind of diagrams, and I don't connect them to anyway. So, okay, a little bit closer. So this is the entire topology for our network. This is the future network. About 40% of this is already implemented. And this is our core. So this is basically our ring topology with the 10 gigabit core. So our core is it's entirely BGP free because we don't have our own AS. There's no need to run BGP in our core. It just adds up complexity that we don't need. It's not like we don't like BGP or that we can't run it. It's just we don't want to. So Ospf is used as the interior gateway protocol, including CSPF for constrained shortest path first so that you can run traffic engineering and using RSVP on top of it. And VPLS, of course, is signaled via LDP because we have a BGP-free core, so there's no other way, except you could do static labeling, but that doesn't make any sense. So, right. So that's the core. So, and on this end, so this is the data center, this is financial and administration, this is the IT lab or the College for Computer Science, and this one here is the high school. So the highest density for mobile clients is over here, over there. So why do we implement a 10 gigabit backbone? Yeah, surely we could have implemented this with gigabit for internet connectivity. Plain internet bandwidth, it would have worked like a champ. No problem. So the reason why we actually implemented a 10 gigabit backbone, well, we could afford it. No, that's not the reason. The reason is basically because we host many services locally. We have a cloud-based storage with more than 40 terabyte that's hosted at the university. We also have our own media libraries, a lot of streaming and all other stuff that will be implemented in the future. So we actually decided to go for this approach to make it future-proof. Right, so we don't have to have, we're not going to have any issues with this 10 gigabit backbone. We have all the flexibility we need. So, and it's also for education. So, I mean, for educational purpose. It was it's a steep learning curve to go through this if you do it for the very first time. But it was fun. It was really fun, seriously. So, this is the routed layout. No, it's not. Why is it not the routed layout? That's it. Yeah, transit networks. So, of course. This entire infrastructure is fully managed and it's fully documented. So we don't do stuff without documenting it. We don't do fire and forget exercises anymore. We're done with that. Okay, we don't implement something and no documentation, and 2 years after when someone else has to take care of it, it's like, good luck. No, not anymore. We've been there and we decided not to go down that road anymore. Ever again. Ever. And per router we have a loopback interface, of course. We have transit networks in between our router pairs. We have a management address per switch, and this is just the distribution, so this is not the edge yet. So what features, I don't want, as I said, I'm not going to bore you with all the command line printouts and everything. I'm not going to bore you with you've seen most of that stuff anyway. So the router configuration mainly consists of a little bit Ospf, tiny bit of LDP, a bit of discovery on the interfaces that are facing the routers, each other. Firewall configuration, of course, less filtering in the core because we want to keep it performant and less complex. That's why we're implementing VPLS. Then we have NetFlow collection. That means all our routers are sending NetFlow diagrams all the way back to the main data facility for display. Unfortunately, the internet connectivity is so crappy that I couldn't actually log, and I'm talking about my mobile connection, okay? I couldn't log into our VPN in the past hour. I don't know what's going on there. Otherwise, I would have showed you the overview for our NetFlow system, which is a really nice graphing system, actually. Also open source. We also use SNMP and Negros. Not Negros, we actually also use Singar, but anyway. We use SNMP and Negros for monitoring and proactive handling of devices. And DNS is handled by separate name servers within the infrastructure. So we don't channel any DNS traffic directly, or we don't address DNS traffic directly to our routers. I hoped I was hiding that frame, that slide, and now I'm there. Okay, so one major issue that I was running into when I did the initial design for VPLS was something that I never encountered with any of the other vendors, including right? So, and the major issue here is, and I hope this is mainly a request for comment, okay? Maybe I'm wrong. We're just all humans, and maybe I just made a mistake or something. But I was addressing this with the support. I was addressing this on the forum. I was addressing this with fellow MikroTik engineers. And the main problem right now is just to make sure that I wanted to make sure that it's not me. It's not layer 8, okay? I wanted to make sure it's somewhere down below. And there's no way, there's no preferred path selection currently implemented with router OS. So what does it mean? So when you create a VPLS tunnel on a router board, or a router OS basically, when you create a VPLS tunnel, it will automatically, transparently in the background create 2 traffic engineering tunnels to cater the traffic. So basically downstream, right, and upstream. So it runs on top of TE. So if there are any pre-existing TE tunnels between the routers, or basically the IP addresses that you use in order, the transport IPs that you use to set up a VPLS tunnel, it will automatically use those tunnels, or these 2 tunnels. So what's the problem with that? The problem is that these tunnels are pre-configured, so they might have bandwidth configuration on them. For example, limitations, or guaranteed bandwidth configurations. Well, so meaning the VPLS tunnel that you just set up was actually assigned to a tunnel pair that was meant for something completely different. So it's occupying bandwidth that is not supposed to be occupied in the first place, and it limits the VPLS tunnel and attaches the constraints of the TE tunnels that are on the underlying part. See, I can see you guys are actually all about to fall asleep. This is the last slide that's boring, I promise you. So let me just finish this. So there's no way right now, as of now, and I hope we can fix this, there's no way to assign a VPLS tunnel to a specific pair of TE tunnels in order to do what MPLS does best. So you can use TE tunnels in order to steer the traffic of VPLS without the need of involving the net filter layer. So without doing rate limiting for bridging, for example. But right now, when you create a VPLS tunnel, what you do is you do rate limiting. You mark the connections and you do rate limiting. Simply, okay, I want only 5 Mbps on this VPLS link. Well, that's ugly because MPLS is not supposed to work that way. That's my idea about it. So, as I said, maybe it's layer 8, maybe it's me. If you know it better, teach me. Come on, do it. But I was digging into this for quite a few weeks besides daily business, and I can tell you it was frustrating. So in the end, I was deciding, okay, go the way of least resistance, and I just configure rate limiting. Well, but it works, but it's ugly because you still have these issues. Anyways, if you can feel my pain, just come to me after the talk. All right, so so that you're not gonna leave empty-handed here. Besides the network design, I also would like to introduce some of the minor tools that helped us to crack our network. OpenNetAdmin. OpenNetAdmin is actually an IP address management tool. It's web-based. It's pretty cool. It has role-based access control. You can hook it up to an LDAP server if you want to. It's pretty cool. It's fairly old. So it has a centralized database. It provides you with a centralized database for all your net blocks, subnets, VLANs, hosts, DNS records, and it's fully integrated with DNS and DHCP. So that's pretty cool because we do all our DNS zone deployment and DHCP configurations, including per subnet-based options and static leases, using one tool. Done. No more by hand configuration. We're done. We have one centralized DHCP server. Everything else goes via relay, and we're done with it. It's pretty nice. So there's support for DNS views, so you can actually mix up private IPs, public IPs, and so on and so forth. So if you have actually a split DNS situation, you have a service hosted internally using a private IP, you do port forwarding, or you assign another IP address to the same host, you can actually create a separate DNS view for the external DNS so that you can reach your systems from the outside, so with the public IP instead. However, and that's the biggest issue right now, due to the fact that it's more or less a legacy system, it works fine, don't get me wrong, but it doesn't support virtual routing yet, so VRF, so basically virtual routing tables, exactly. So that's bad. That's really bad. However, there's help. Just going to show you a quick screenshot. This is the dashboard. So this is actually taken just before we got here. So right now we have about 84 subnets. We have about 5,300 hosts on the network. We have about 5,400 interfaces, 10,930 DNS records. DNS domains 63, 33 blocks, VLAN campuses 6. So without this, without an IP address management platform, I would never start a project, period. It's as simple as that, especially when you work with more than 2 people. It's incredibly frustrating if someone actually takes an IP address and all of a sudden you go like, oh, wait a second, this one is twice in a routing table. Now I have like ECMP for these 2 routers over there, and you have to debug this for the whole day, just because someone actually didn't watch what he was doing. That's agonizing, I can tell you that. This is preventing it. So this is the list of, this is a sample list for, subnets. You can see here, we name them according to source router, destination router. This is the DC, the data center, first cloud core router, .rt. This is our subdomain for routers. To SG Bank, this is the SG Bank router. And this is the subnet that's allocated for the transit host. So then, this is subnet allocation, so you can really unfold the subnet and just do whatever you want with it. It's pretty nice. You can put in descriptions and stuff. And if you're not satisfied with OpenNetAdmin, here are 2 alternatives. NEPUB, pretty recent, pretty new, fresh project. It has support for VRF, but no integration for DNS DHCP. So for us, of no use. The NOC project, which is fairly old already, it's Java-based, if I'm not mistaken. Actually, many tools, also Perl scripts and stuff. Steep learning curve due to large complexity. So if you really want to use this, it helps you well only if you train yourself or your people. It integrates with MikroTik and Cisco, which is a key factor, so you can actually manage MikroTik devices with it. I haven't tested it fully. I've been just playing around with it for a couple of weeks, besides daily business. I can't promise you that everything works out of the box. I'm just telling you that this is a tool that you might want to check out. The same thing for, maybe next time I'm just going to put a black bar right here. I'm so sorry. SNMP-based incident and fault handling, so it can poll for information. It can also be an SMP management console, management server to receive traps from your SNMP devices. You can do monitoring and notifications, and it has full integration for DNS and DHCP provisioning. Any questions? That was a lot. You just survived 44 slides.